Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So let's continue our study on geometry treasure. We are going to talk about the property 3 and property 4 of the incenter, excenter, incircle, excircle. Property 3. Let circle I be the incircle or excircle of triangle BC. Circle I is tangent to sides BC, CA, AB on D, E, F respectively. Line DI meets line EF on K. AK meets BC on M. Prove that M is a midpoint of BC. So the problem set looks like not very difficult. Right, it's very straightforward. So let's just draw the figure first. As I showed before, that I want to draw the incircle first. Right, and okay, this is our triangle ABC and circle I. Right, circle I is tangent to BC, CA, AB on D, E, F. And we know that we want to connect EF. And we know DI meets EF on point K. And AK meets BC on point M. We want to prove that M is a midpoint of BC. Right. Remember we did this in property 2, that we actually has a DI meets a FE on a point P, and we connect AP meets BC on G. We proved that BG equals to CD. And how did we do that? We did a parallel line passing through P, BC parallel line passing through point P, right? And then we find that we can find the relationship of the angles, right? For this problem, it's a similar thing. Let's just do the parallel line first. Right, think about it. We want to prove that BM equals to MC, which means we just need to prove this segment equals to this segment because they are in parallel, right? So let's call this point as C prime, this point as B prime. And now we can connect IB prime, connect IC prime. Why? Because we already know that we want to prove, right? We want to prove that B prime K equals to C prime K. And we know that DK is perpendicular to B prime C prime. So if B prime K equals to C prime K, that means IB prime equals to IC prime, which means we can just find a way to prove IB prime equals to IC prime in order to prove that B prime K equals to C prime K, right? Now let me just write all of this down. So we want to prove that BM equals to MC, which is equivalent to prove that B prime K equals to C prime K, which is equivalent to prove that IB prime equals to IC prime. Right, we want to prove IB prime equals to IC prime. And related to I, we have the ID, we also have the IF and IE. So if we connect IF, we connect IE. We notice that angle B prime Fi equals to 90 degree equals to angle B prime Ki, which means B prime F K I. These 4 points are cyclic. Similarly, angle IKC prime plus angle IEC prime equals to 90 degree, right? This is 90 degree, this is 90 degree, sorry, this is 180 degree, which means IKC prime E are cyclic. Okay, we got that these 4 points are cyclic and these 4 points are cyclic. Because these 4 points are cyclic, right? And these 4 points are cyclic. So we know that angle FKI plus angle IKE equals to 180 degree, right? FKI plus IKE equals to 180 degree. That means angle IKE equals to angle FB prime I, right? The angle IKE, this one, equals to this one, FB prime I, right? This one equals to this one. And because KIE C prime are cyclic, so angle IKE equals to angle IC prime E. So look at these two triangles. For the triangle IB prime F and the triangle IC prime E, right? For these two triangles, we know that they are all right triangle, and also the angle IB prime F equals to angle IC prime E, and IF equals to IE. That means these two triangles are congruent, which means IB prime equals to IC prime. So we know that B prime K equals to C prime K, which means BM equals to MC, which means M is a midpoint of BC. Okay, that's property 3. Let's look at the property 4. So for property 4, it's a very interesting problem. I'll show my solution, but I would say I want to find a better solution, but I couldn't. So if any audience can find a pure geometry solution, please contact me if you would like me to make a video to talk about your solution. Okay, let's see the property first. The property 4 is saying that let circle I be the incircle or excircle of the triangle ABC. By the way, I didn't show the excircle proof, but the method is exactly the same. So just to make the video short and clear, please, audience can prove the excircle case by yourself. Okay, property 4. Let circle I be the incircle or excircle of the triangle ABC. M is the midpoint of BC. AH is the altitude of side BC. Notice that now we look at the altitude. So let's redraw the figure. Let's actually finish this, reading this. AH is the altitude of the side BC. Q is a point on H. The length of AQ equals to the radius of circle I if and only if Q, I, M are collinear. We just need to remember this one, right? Q, I, M are collinear. Okay, now let's draw the figure and think about the problem. So the first thing is to find the incircle here, and So we have A, B, C, right? This is point I. Notice that we already know M is a midpoint of BC. And what else we know is that AH is the altitude, right? AH is the altitude of the triangle on BC sides, and Q is a point on the AH. AQ equals to the distance, the radius of the circle I, if and only if MIQ are collinear, right? If AQ equals to R, then we know that MIQ are collinear, right? Or if MIQ are collinear, then AQ equals to R. Right, we want to prove this. Notice that what is R? R is, if we call this tangent point as D, this point tangent point as Z, this tangent point as F. So we know that ID equals to IE equals to IF equals to R. Right? So the first, very straightforward thinking is that if we can, for the case that we want to prove that AQ, in the case that AQ equals to R, which means AQ equals to ID, right? We want to prove MIQ are collinear, which means that we just already know that AIDQ is a parallelogram, and we want to prove that MIQ are collinear, right? So we should be able to find a way to use the conclusions that AIDQ is a parallelogram, but I didn't find a good way to do that. So if anyone can find a better solution, please let me know. So my solution is very brute force, so we can do the calculation. Let's consider about the second one first. If MIQ are collinear, then AQ equals to R. We want to do this proof. So let's just say MIQ. We already know they are collinear. We want to find the length of AQ. The first thing is that we want to calculate for the length of AQ. So AQ equals to AH minus QH. Right, which means that we want to find the length of AH and we want to find the length of the QH. How can we calculate for length of AH? AH equals to twice of the triangle area ABC divided by the length of BC, right? That is A. So twice of the area of triangle ABC divided by A, that's AH, that's the altitude. What is QH? We want to find the QH. So QH can be calculated based on the ratio of ID to QH, right? And we know that ID to QH equals to MD to MH. Right. ID to QH equals to MD to MH. And how can we calculate for MD? MD equals to MC minus DC. And what is MH? MH is MC minus HC. Right? So MC equals to half of the length of BC, so it's A divided by 2. And for DC, right, we know that DC equals to CE, and AE equals to AF, BF equals to BD, which means CD we can calculate it very quickly, right? Twice of CD plus twice of AE plus twice of BF, that's A plus B plus C, which means DC plus AF plus BF equals to half of A plus B plus C, right? That means DC plus C equals to half of A plus B plus C. So we got DC equals to half of A plus B minus C. Right? That's the length of DC. Now we have the MC, we have length of DC. Let's consider how can we calculate for HC. HC equals to AC times cosine angle C. Right? AC times cosine angle C. The length of AC is B. Then we want to find cosine angle C. So we can use the cosine law here, that cosine angle C equals to A squared plus B squared minus C squared divided by 2AB, right? Then we know that HC equals to AC is B, so A squared plus B squared minus C squared divided by 2A. Now we get everything we need just to do the calculation here. So ID to QH equals to A divided by 2 minus DC. DC is A plus B minus C divided by 2. Divided by A divided by 2 minus HC. HC is A squared plus B squared minus C squared divided by 2A. Right, so for the nominator, it's we have A divided by 2 cancel each other, then we got half of C minus B, right? Divided by this one can be rewritten as this. Then we know it equals to C squared minus B squared divided by 2A. So it equals to A divided by C plus B. Right, that's ID to QH. And what is ID? ID is the radius of the circle I to QH. Right, and we want to find the length of QH, which means QH equals to R times C plus B divided by A. Right, that's QH. So eventually we want to prove the length of AQ. AQ equals to AH, which is twice of the area of triangle ABC divided by A minus QH. QH is R times C plus B divided by A. What is R? R can be rewritten as twice of the area of triangle ABC divided by A plus B plus C. Right? And that's R times C plus B divided by A. Right? So this one equals to twice of the area of triangle ABC divided by A times 1 minus C plus B divided by A plus B plus C. This one is A divided by A plus B plus C. And this A can cancel with this A, so we got twice of the area of triangle ABC divided by A plus B plus C, which equals to R. Right, that's how I force brutal solve this problem. And for another case that we want to find if AQ equals to R, then we want to prove that MIQ are collinear. It's actually just the reverse calculation for it, because we can just say we already know the length of HC, so we can find the length of DH, right? And because we already know that AQ equals to R, so we know the length of QH, and we know the ratio of ID to QH, which means that we can, based on the length of DH, the ratio of ID to QH, find the length of MD, and we already know the length of DC, MD plus DC. We just need to prove that MD plus DC equals to half of A, and it's just as a reverse calculation, right? Okay, that's for today's problem, and the property of the incenter excenter. I hope you like this video. See you in next one. Thank you.